I am here to discuss the so-called flying saucers.
We know now that in the early years of the 20th century, this world was being watched closely by intelligences greater than man's.
Did the CIA write Wind of Change by the Scorpions?
As humans busied themselves about the various concerns, they were scrutinized and studied.
Dr. Loeb, what percentage chance do you give it that you have indeed uncovered extraterrestrial or non-human technology?
With infinite complacence, people went about their affairs, yet across an immense ethereal gulf, intellects vast and unsympathetic drew their plans against us.
All of a sudden, a stick out of nowhere landed right in front of us, and there was no tree, nothing overhead. Something threw it at us.
Yeah.
All Things Unexplained.
So some of that, I think, sir, we'll save for closed session.
All Things Unexplained is free to watch on YouTube and listen to wherever you get your podcasts. If you would like to support our show, you can visit our YouTube store. Additionally, you can find us on Venmo under All Things Unexplained. Be sure to check out our website, allthingsunexplained.com. All proceeds from the sales of Dr. Mounce's books on Amazon and Audible also go straight to our show. Okay, welcome everybody to All Things Unexplained. We are so excited to have lots of people watching live with us. If you're listening to us later on podcasts, thank you for joining. We have such a great show for you today. We have author of the new book, The Cosmos Explained, host of the podcast Into the Liuniverse. He's an associate in astrophysics at the American Museum of Natural History, a professor, a talented singer, which we have proof of from earlier tonight, co-author along with Neil deGrasse Tyson and Robert Arion of the book One Universe at Home in the Cosmos. And I think that's all the time we have for the show. So thanks for tuning in. It's Dr. Charles Liu. Thank you for joining us.
Thank you so much for having me. What a pleasure to be here.
Yes, we are so thrilled to have you. And wow, what a record you have there of all of the things that you've accomplished. We're grateful that you are joining us on our show. We've got lots in store for everyone tonight. Those of you that are joining us live on Facebook, we will be doing a section where we will take listener questions and give those to Dr. Liu or Chuck or Charles or however you would like to address them tonight. I'm going to go with Dr. Liu. So please do share those comments and questions with us. And I've got Dr. Mounce with us here this evening. Hello, Dr. Mounce. And I've got Smitty Neves.
Great to be back.
And if there's no other housekeeping, we'll dive right in. Any questions or comments before we get going, guys?
It's just good to have you with us, Dr. Lou.
Oh, it's so nice to be here with you. Thank you. Oh, Dr. Mouse, you're waving my book around. That's so kind.
Tremendous book.
We
available
actually
on Amazon.
We tried to make this book accessible to everybody. You see that the cover isn't like some fancy thing, right? But it's designed to be. Oh, you too, CJ. Oh, thank you. Yeah, the drawings, the art. It's all designed to tell people, look, the universe is not this foreign thing that's so far distant from us that we can't understand it. We are part of the universe, and the universe is part of us. We are as cool and as ordinary and as mysterious as everything else in the universe, be it a planet, a star, a galaxy, or even the cosmos itself.
Yes, honestly, you did such a good job of that. Truly, you told wonderful stories too. I felt like this is coming from the girl that cried in her freshman year of college in my astronomy final because I couldn't understand any of it. And truly, I felt like I'm going to fail this exam. I left so defeated, and so I gave up on science altogether until later on in life, and I found a new love for it. But in this book, I felt like, okay, this is really broken down in a way that sleep deprived, children have sucked all of my brain cells away. I can understand it. And there's pictures on every page, truly. So that's great. So what inspired you to do this book in the way that you did?
Well, coincidentally, it's kind of like the thing that inspired me was sort of what drove you to tears in your astronomy class in college. On behalf of all astronomy professors, I apologize for having done such
It
a
wasn't
bad
mistakes.
job on behalf of all of us, right? Of not conveying to you the wonder and the beauty of the cosmos in the way that you were able to receive it or wanted to receive it at that time, right? If we think about it, you can get incredibly technical about the universe, right? Cosmology with nucleosynthesis and nuclear fusion and Schwarzschild radii of black holes and the first stars and initial mass function. I could throw huge amounts of technical information at you, but you wouldn't get the story of the universe from its beginning to the present day and beyond. To me, telling the story was so important. And so when we had the opportunity to say, look, this wonderful publisher, Ivy Press, who came to me and said, what kind of story about the universe would you like to tell? They were thinking about like a history, like a timeline. And I said, I want pictures, but I want those pictures not just to be decorative or ornate. I want them to be scientifically accurate. So people can learn about the universe, what we know about the universe, and what we still don't know about the universe through pictures, as well as through words, as well as through a timeline of history. All these things combined together. And so this was my way of trying to create a story of the universe that anyone could pick up at any point, right? In the chapters, you can learn one part of it. But overall, you can learn the whole thing about it and enjoy it no matter what, and not feel like it's, not for you, right? And you're saying, CJ, I want this to be for you, right? And for everybody. That was what inspired me to write the book in this way.
Yeah, well, you did a beautiful job. And I read the whole thing and I truly felt like I understood so much more than I have before. So thank you for doing that. And you did do it on a timeline. And one thing I noticed was, chapter 1 was what? Negative. What second were we at in chapter 1?
10 to the minus 43 second after the Big
Yes.
Bang.
I love chapter 1, the first quadrillionth of a quadrillionth of a second.
Of a second. Yes.
Right.
So a lot happened then. And then you
Yes.
jumped to 5 minutes after the Big Bang. And then we jumped to 400,000 years after the Big Bang. So what would you say in that time from 5 minutes to 400,000 years? What is the most important thing for people to understand that happened in that span of time?
It is that the universe was expanding. See, when we try to compute time in the cosmos, one of the most intuitive ways to think about time is measuring how much the universe has expanded since time equals 0, right? The Big Bang, the moment that time began to run. And as a result, the expansion of the universe is an increase in space as well as in time. It's still expanding today, and it continues to do so. And that's why we can keep track of cosmic time the way that they do. So during that time, nothing, say, exciting is happening, right? We picked 5 minutes because that's the time when the first atoms are forming. They're not even neutral atoms. They're atomic nuclei and electrons and light particles, photons, that are swirling all around one another. But between 5 minutes and 400,000 years, what happens is that the universe expands enough so that the light and the matter, the massive stuff like the hydrogen nuclei and the helium nuclei, can actually start to move independent of one another, something we call decoupling. And when that happens, that allows gravity to start doing its thing in the universe, that is, making things like planets and stars and eventually plants and people. And it allows the light to stream across the universe so that we can see what is going on other parts of the cosmos. That light imprint from 400,000 years ago is today, we call it the cosmic microwave background radiation, because it used to be as hot as the surface of the sun, but now it is so cold that we actually sense its temperature through AM radio. It's that cold. So that's the kind of thing that happened, that transitional period between when matter and energy were all interlocked and kind of dragging on one another, to the time when they began to stream freely of one another and allow for the rest of the universe to be built.
Wow.
Awesome.
Dr. Lou, something
Yes.
that I had a hard time wrapping my brain around, and throughout the entire book, it kept coming back to me like it's haunting my nightmares almost, is at the very beginning of the book, at that first quadrillionth of a second, you say that there was a singularity, zero density, and infinite volume. And I just find that so difficult to comprehend.
Right. The idea of a singularity, infinite and zero volume, has a circumstance. It actually is rooted in math. In true physics, originally, hundreds of years ago, there was really no way to imagine something like that has no size and yet actually has some sort of mass, which means that it is infinitely dense. And mathematicians, hundreds of years ago, started thinking about this. I'd say around the 1700s. They're like, you can actually create a circumstance on a math page where you can have that kind of singularity, but you can't do it in real life. So there was a lot of mathematical theorizing and actually proofs and really careful calculations about how you can deal with a singularity in the world if one ever existed. No one thought of one ever would. But then we realized that they could, because Albert Einstein's general theory of relativity explained that space isn't just a sort of emptiness in which stuff exists. Space is actually its own thing that grows and can also thus twist and bend and warp, kind of like a 3D version of a trampoline or a spandex swimsuit or something like that. And if you can twist spandex, right, and or space-time or anything like that, then you can make a singularity, and that's where your first inkling that a singularity could exist could have happened. A couple decades after that, heck, not even within 10 years, brilliant mathematicians were saying, "Hey, I recognize this bending stuff and the ability to make singularities." And in fact, it was a Belgian priest, a guy named Georges Lemaitre, who came up with the idea, you know what? If the universe is expanding, then that means at one point the universe could have been so small that it was at zero volume, and thus it had to have infinite density, and thus it was a singularity. And so was born this idea. Georges Lemaitre called this the primeval atom. We today call it the Big Bang singularity.
So is that just one of the theories of how the Big Bang could have happened? Because I recall reading something that you wrote about possibly two multiverses touching and creating our universe.
Right. That's a great point, and this is where we're talking about that math now, right? We at 1/4 of a second, right, all the way to zero. Even though it is a really small number of seconds, there's actually a really long way mathematically to actual 0, 0, 0, right? So our physics really can only explain the universe starting from about a trillionth of a quadrillionth of a second after the singularity. All right. So the singularity itself, all the way down to that 0 point, can only be explained mathematically. And therefore, we haven't been able to show whether or not that singularity existed because two 5-dimensional universes actually came in contact, kind of like a couple of soap bubbles in your children's bath, right? And thus created a skin of sorts, which is a 4-dimensional space-time, which is our universe. Or if somehow there was something that existed, but then kind of blew up in size within some larger structure. Again, not a space-time like our universe, but some other structure with 3 or 4 or more dimensions, maybe 10 or 11 dimensions, things that we can't grasp in our daily lives, but can exist mathematically. And as with all science that's at the cutting edge, the challenge for scientists is to say, okay, these are hypotheses, these are good ideas, and how can we confirm or falsify them? Whether or not they're true or false, we have to design experiments to test them. Up to this point, we astronomers and physicists are pretty confident that we've been able to test the Big Bang theory to be correct all the way down to about a quadrillionth of a second after the Big Bang. and then all bets are off. There's where that multiverse thing can happen. There's where that strange multidimensional thing can happen before that threshold in time.
What's your favorite idea of what it could be? What do you want it to be?
My favorite idea is the one that hasn't been thought of yet.
Okay.
I really think that people are onto this thing. The 5-dimensional membrane connecting to create the 4-dimensional space-time idea has been developed primarily by Lisa Randall at Harvard. She and Balasundaram, I don't know where he is right now, but they kind of built this idea where you could have these dimensions connect with one another and thus explain a lot of our uncertainties about our own universe. For example, why is gravity so dominant on large scales, yet completely insignificant on nuclear scales, right? So that's sort of where we are at the moment. I think people are close to the truth, but there is something there that's still missing, and people really recognize that. Even, people like Randall and Sundram, or all the other people who are working on things like eternal inflation, Alan Guth's inflationary model. There is another, I'm just throwing names out, don't worry. You can go look them up if you're interested. But the bottom line is, I think they're all kind of close. They'll kind of like see different parts of the elephant, but they haven't seen the whole elephant yet. So I'm waiting for that thing that ties them all together.
Waiting for the elephant. Okay, I like it.
Yeah.
I like Stacy's comment here.
Yeah, that's great. Listener Stacy David Severn says, I think I just learned that my bathing suit has infinite density. Mind blown. Sounds like a problem, though.
That's awesome. Okay, well, in the book, which is based on a, what was that, Smitty?
So I don't think it's a problem if you like to eat a lot. I mean, it's long as it's done.
Oh, so in your book, you do everything on a timeline, before, current, what's happening in the future. As elementary as you can you explain
Okay.
how scientists and mathematicians date these events? How do they figure out when these things happened?
Great question. What we have to do is to figure out on a cosmic level how to translate the expansion of the universe to the seconds and hours and minutes that we're used to counting time with. And the way to make that connection, astronomers use a tool called redshift. It turns out that the way the universe is expanding, it causes every spot in the universe to move away from every other spot in the universe. And as a result, if I measure something far away, that means it's probably moving faster than something that's closer by on a cosmological scale. An analogy I like to use is fireworks. Every time a fireworks shell explodes in the sky, it turns into a big, beautiful flower kind of right away. That means that the things that got to the edge of that flower had to have moved faster than the stuff that moved in really close. So the expansion of a fireworks shell is like an analogy of how the universe is expanding away from us, and distant galaxies or black holes are being carried along for the ride. So astronomers have spent almost 100 years now trying to measure the relationship between how far away an object is and how fast it moves away from us because of the expansion of the universe. Once you get that speed, you can translate that speed into a distance, and that distance into the amount of time it takes for light to go from that distant object to us. And from that, we can then get a number of years ago that it happened. So that's the indirect way we get all the way back to the Big Bang. Now, after the Earth forms, we have a new technique. I don't want to go too deeply into it, but it has to do with radioactivity. And that is a really nice way, right around 4.5 billion years ago, when the Earth formed and the Sun formed, that we can start figuring out time based on atomic clocks that nature has provided for us since our Earth was formed.
Awesome.
Yes, so much.
For those that are just tuning in with us, We're chatting with Dr. Liu, author of the new book, The Cosmos Explained. Go pick up a
There it
copy
is.
today. I'm telling you, it's beautiful, number one. It's very easy to understand. Every page has some sort of image. It's
Available
really
on
great. Very
Amazon.
well done.
That's where we got ours. Gets to your house in 2 days. Also, the host of his own podcast called The Liuniverse, Liu, Liuniverse.
Into the Liuniverse, right? Is it Into the Liuniverse?
The Liuniverse is, I
Liuniverse,
think,
okay.
the official title, but Into the Liuniverse, people talk about that way too. I have to tell you that I didn't come up with that idea. I thought the Liuniverse, it felt a little self-indulgent, but everyone else around me said, that's the obvious name for the podcast.
Yeah, I think it is.
And I
It's
was
wonderul.
hoping.
I-
Well,
Yeah.
I thought you were
the
gonna.
people like it.
I thought you were gonna credit Stan Lee for a second.
Well, I am a
Stan
true
the man.
believer, so face what?
Oh,
Fearless fan.
okay. Well,
I was
I have
a
a.
comic book fan a little long ago.
Are you a comic book fan? Tim was wondering.
time.
Dr. Mouse was wondering.
I mean,
It's like
I could
that
kind
could
of
be a whole
tell.
separate show, boys. Settle down, settle down. We'll do another comic book show.
Yeah, we
I can
definitely
see it
need to
happening
do
But I've
already.
got so many questions about the
Spiraling.
Avengers,
It's
X-Men,
spiraling out of
Spider-Man.
control.
Can't wait
Okay,
till
well, we'll-
all the universes are melded together. It's been set up now so that the next TV shows can all like have X-Men and Fantastic Four and Spider-Man and the Avengers all together. It'll be fun.
No Doctor Strange 2 spoilers. I know you've seen it. I haven't seen it yet.
it.
But I do
Mum is the
know
word.
I do know Wanda does some bad things. I'm not gonna. I do know that, but I haven't seen it. We did a few shows on WandaVision.
Oh, really? Did you talk about the ship of Theseus?
No.
I
No, we
loved
did
that.
not.
The best part, in my opinion, of the entire movie, television, podcast, whatever series so far was the. Dare we spoil this a little bit? I mean, it's been a little
Go
while,
for it.
so I think it's
Let's do
okay.
it. Warning,
When the-
spoilers.
Okay, spoiler alert in 3, 2, 1. When the white vision is up against the multicolored vision, and they're circling in the library,
Oh, yes.
and they're trying to talk to one another, they present a marvelous dialogue, which I think is the very best dialogue, like I said, of the entire franchise so far. And the person is trying to the real vision, or the provisional vision, is trying to explain to the white vision who they are, right? He says, I presume you're familiar with the metaphysical paradox, right, known as the ship of Theseus in identity
Yes.
metaphysics. Right?
Yes.
And then the white vision says, naturally, the ship of Theseus is an artifact in a museum. Over time, its planks of wood rot and are replaced with new planks. When no original plank remains, is it still the ship of Theseus? Right? And then secondly, if that old wood is repaired and cleansed of the rot and reassembled, is that the ship of Theseus? And the two of them think, and they say, both are the true ship. Neither is the true ship. It's amazing. It's amazing. I loved it. I thought it was awesome.
Total paradox. We can.
Should have watched that.
We
show
don't
with
have to
you.
hang around too much on this, but my theory: White Vision is off to the West Coast to start the West Coast Avengers. That's just my theory.
Well, in the 80s and 90s, Vision. This is comic book stuff now. And again, I'm betraying my age and my childhood. but the Vision basically decides in his logic that it is appropriate for him to take over the world because the world is just so terrible that he should just run the world. But then he eventually sees the error of his ways and self-destructs in order to save the world from an evil version of himself, basically. And what is left is this sort of white version, a ghost-like vision. And that creature has to develop an identity and restore his love for Wanda and how to live and things like that. And the whole West Coast Avengers stuff, that's all part of it. Yeah, the Vision started the West Coast Avengers before he turned white because that was part of his grand plan to take over the world. It was very interesting. He wanted to split the Avengers up so they couldn't concentrate and defeat him. Anyway, too much fun stuff. I'm so sorry.
Just
on
so,
and on and on.
just so you know, we are all still waiting on Mephisto. Like, where's Mephisto? What's going on here? But anyway.
Yeah.
I'm thinking anytime now Mephisto's jumping out, but it didn't happen. Sorry, CJ.
Well, for me, Dormammu is good enough for me.
Yeah,
all right, sorry. Please continue.
No, that's great, mate. You should come back. We need to come back and have a Marvel show.
Yeah,
yes,
a Marvel
that would be
show.
awesome.
It shall be. Okay, we're gonna circle back to the book. We'll table the Marvel comic talk for another episode because I can see what's gonna happen already. It's gonna happen. Okay, so back to the book. Dark matter. Lots of discussion about dark matter. Lots of question about dark matter. Seems a very important piece to the puzzle of our universe. Do we know anything about dark matter other than we know that it must exist?
We know what it's not. Does that help?
Sure.
We know that it's not made out of protons, neutrons, or electrons, or literally any other particle we've ever discovered. We know that the quantum mechanics of what we understand today, often what we call the standard model of particle physics, cannot explain the existence of dark matter. So what's happening is that right now, experimentalists are trying to find exotic new particles. They've done all kinds of interesting experiments deep underground, both in Europe and in North America and elsewhere. They're trying to see if some particle could be found that could explain all this, and they haven't. They've only been able to place upper bounds on the existence of these things. They keep having to change and adjust. Their original hypotheses are proven to be incorrect, and so they're readjusting their hypotheses to try to understand it. All that we know is that we know it's not those things. But when we astronomers look out in the universe, it is totally there. Absolutely there. The existence of dark matter has been confirmed again and again and again with every galaxy, with every cluster of galaxies, with every large scale motion of the universe that's measured. We know more and more for certain that for every pound of stuff that are made up of protons and neutrons and electrons, there are 4 or 5 or even 6 pounds of stuff that are not.
Wow. And
we're going to take questions later, but this one seems valid at the moment. Is dark matter the same as antimatter?
Great question. Dark matter is not antimatter. Antimatter is matter particles of the kind that we know exist currently, things like electrons, for example, but with the opposite electrical charge. So, for example, the antimatter version of the electron is called the positron. The antimatter version of the proton is called the antiproton. And we know, we have measured very carefully, and we are certain within experimental errors, that the dark matter out in the universe is not made up of things like positrons and antiprotons and things like that.
Okay, great. I agree, Trent. Smart people are awesome. And smart people can sing too. Dr. Liu, I'm going to put you on the spot. Because my next question is about black holes. And I've had this little ditty stuck in my head from your Instagram account. And I've literally been singing it to myself every single night. So would you sing us your black holes song?
Let me first say, by the way, that this comment that smart people are awesome. Yes, it's true, but you know what? Not smart people are awesome too. In fact, this is something I really would like to get across.
We're good.
I do not consider myself a smart person, in the sense that we people are all essentially as smart. Like within a bell curve, we are all basically the same level of intelligence within some order of magnitude. There's no single human being that is so remarkably more intelligent than everybody else, that we wind up having to think of them as being on a different level. What we do instead is that we're just a little bit better at this, a little bit better at that. I am maybe really better at thinking about the universe because I've been doing it for so long, but Steph Curry is better shooting the 3-point than I am, right? And different people do different things better, and that's just sort of, we're all smart in different areas. I think that's a really, really great way to put it. So please don't think of this as intelligence, but think of it as interest and what I like to do and what I like to think about. And all of us are in that same boat. We really are. Okay, the song.
Yes.
Not the 74. We owned a 77 Plymouth, Dodge Aspen, which is, the version of the Plymouth Volare back then. So I can't do it anymore because that car is long since disintegrated. But that's a great question about the 77. And I can't do it. No. Okay, black holes. The thing
yes.
that the reason this song came about, CJ, and you may know this already, but it's that a lot of people think that black holes are like these giant vacuum cleaners, right? They just sort of suck you in, and that if you come near them, a regular black hole will come in and just like absorb you. It turns out that black holes actually are much more innocuous than that. They're very pleasant, actually. If you stay far away from them, they don't bother you at all. In fact, if the sun were to become a black hole today, we would not suddenly be sucked in toward the sun. There would be other kinds of radiation things that go on, like our sunlight would be replaced by X-rays and things like that. But really, gravitationally speaking, it won't cause us any more trouble than the sun does unless we get close to it. When we get into it, when we get to its event horizon, it's called, then they're stuck. Then that's your new home. You are not leaving. That's the inspiration for this song. And so that's why I take a cue and I thank Harry Belafonte for the melody. And it goes like this. Black holes don't suck, but if you fall in one, then that's your new home. No, you want to join in? They don't suck, they don't suck, they don't suck, they don't suck, they don't. But if you fall in one, then that's your new home.
Yes. Hooray!
Yeah, good job. Good job.
Seriously, I went to sleep
Yes,
last night and that was just going over and over in my head. So black holes don't suck. If you get to the event horizon, you're stuck there. And I've heard Dr. Neil deGrasse Tyson use the term spaghettified several times about once you enter a black hole. What does happen, or at least what do we think happens when you get to that event horizon?
Great question. Great question. So the term spaghettification was coined by Sir Martin Rees, who was the Astronomer Royal in the UK back in the 1990s. Brilliant man and a great communicator. He wrote a whole bunch of books about cosmology and stuff because he was a theoretical cosmologist. When black holes spaghettify you, it's because when you get close to the center of mass of an object, that the tip of your nose is actually being accelerated by gravity faster than the back of your head. And as a result, you get stretched out like a noodle. Okay, so it depends on how big or how massive the black hole is, that differential pull, right? That tidal difference it depends on its strength. So if it's a black hole, say, the size of a city or the size of the Earth, right? Then the tidal pull is very, very strong, and you get basically pulled into a stream of atoms. I like to think as if you were being extruded from a tube of toothpaste. So it's pretty dramatic.
It's graphic.
But supermassive, yeah. When you have a supermassive black hole, millions of times the mass of the sun, something like the supermassive black hole in the middle of our Milky Way galaxy, it's called Sagittarius A star. It turns out that the event horizon, the point of no return of the black hole, is actually millions of miles away from the center of mass of the black hole. So the tidal effects that your nose feels compared to the back of your head is actually not that great. So your bodily integrity might actually stay a little bit better than you would otherwise have stayed when you're coming into a smaller black hole. And so what happens then? You actually start to feel the gravitational distortion of space and time as you're going in. So you are coming into the black hole and you're just humming along, black holes don't suck, like that. But somebody outside watching you will actually see you start slowing down. Black holes don't suck, but if you fall, like that. So basically, your time is being distorted. You experience time compared to the rest of the universe beyond the black hole at a different rate. And what will happen is the light that comes off of your body, okay, let's say I'm wearing some sort of a blue shirt, the light will start getting stretched as well. A regular blue light wavelength will get stretched toward the red. Red light will be stretched toward the infrared. You'll essentially become invisible as the radiation off of your body gets stretched to infinite wavelengths. And then you fade away, you touch the event horizon of the black hole, and the black hole literally rises to meet you. You become one with the black hole at the event horizon, and you never actually even enter it. As far as you know, that black hole might even be hollow. But when you reach the end, time stops flowing for you. You can no longer see or sense or see anything that's going on in front of you or behind you. Instead, you have just become one with this amazing object in the universe.
Okay, well, that answers Jason Stifler's question. Does time stop in a black hole, or is it considered infinite time once you are in a black hole?
Right. That's a great question. And we, if we think mathematically, we do not know how time works inside a black hole. We only know that time stops at the edge of the black hole. Inside the black hole, there might be a whole nother dimension we would consider to be like time that we are thinking about, right? But that dimension is not something we can measure because no information from inside the event horizon can come out unadulterated from the inside outward.
Wow. We're speaking to Dr. Charles Liu, author of The Cosmos Explained. You can pick this up on Amazon, host of the Liuniverse podcast. Dr. Liu, one thing I've noticed since the singularity and throughout all of astrophysics, and including black holes, the speed of light seems to play a critical role in everything. Why is this?
Well, Albert Einstein codified this in his special theory of relativity back in 1905. What people were noticing was that light simply behaves differently from other kinds of particles. Things like protons and neutrons and electrons, they have a certain way of behaving. And as a result, they change over time. You can actually see them evolve in not like Darwinian evolution, but change based on the environment that they experience. But light, turns out, does not really experience time as we understand it. A photon, a particle light, or a wave of light, once it is emitted, it goes and goes and goes, and it doesn't change. Once it hits something, it doesn't change so much it's destroyed and is recreated again in a different way, either with a different wavelength or a different frequency or something like that. And so light speed is as fast as something can go because it has no mass. Anything that has mass cannot go as fast as the speed of light. And because light has no mass, it is the speed limit of anything moving from one part of the universe to the other. The universe itself can actually, ironically, expand faster than the speed of light. The space in space-time can go faster than light, but matter in space-time cannot.
Great question. All right. Well, I could ask you 1,000 more questions and have a conversation for another 6 hours, but I want to respect your time and everybody else's time. And Tim and Smitty have some fun things they're going to dive into. But before we do that, we'll take some listener questions.
Yes.
Everybody that's listening, please do go get yourself a copy of The Cosmos Explained. It is phenomenal. You will not be disappointed, I assure you. Tim, did you see some good questions pop up there? And
Yes,
else that has some, go ahead and type them up now.
I've earmarked some listener questions here. So Dr. Lou, let's start with listener Willie Mounts, also known as Anonymous Brother. Do you believe God created the heavens and the earth perhaps through the Big Bang?
Great question. I do not know. Even Georges Lemaitre, the scientist, mathematician I mentioned earlier, that was first conceived of the idea of the Big Bang, was very clear in saying he did not know whether or not a god or many gods or some non-natural or supernatural creature or being was behind the Big Bang, the creation of the universe as we understand it. In other words, my personal belief doesn't extend from the science realm into the religious realm. I believe that science and non-science can coexist without any conflict. And the only conflict is created when people want to use one or the other to exert some sort of social influence. So God could have created the universe. God could have had nothing to do with the universe's creation. But in either sense, I'm okay with whatever the result is.
Great answer. This next listener question comes from listener Trent Leonard, Dr. Lou, and you had so many great illustrations in your book that dealt with this, the expanding universe, and how far out our senses can reach and what's beyond. Listener Trent Leonard wants to know, okay, universe growth is expanding faster, but what is past that? What's it expanding into?
We're pretty sure that whatever it's expanding into, it's not more universe. In other words, we are in a four-dimensional space-time, right? We have three dimensions of space, length, width, and height, plus this dimension of time that we're traveling through. When the universe is expanding, it must be expanding into something that has additional dimension, okay? It could be, for example, this five-dimensional membrane to which I referred to earlier, the Randall-Sundrum theory, which is sort of tried to explain that our universe is connecting two five-dimensional structures, and thus we wind up being a four-dimensional space-time that sort of bridges the gap between them. Another idea which has recently come about, and people are trying to work this out, and I'm sorry if I'm belaboring this point, it's playing back into multiverses, but this is an idea that has come about. We were trying decades ago, maybe 50-ish years ago, as scientists, not me because I was, not around, but people were trying to figure out certain aspects of the geometry of the universe. Why was it the way it is? And by doing that, people came up with an idea that at one point, very early in the universe, right around that quadrillionth of a second moment, the universe, for some reason, didn't just expand, but it inflated. So for a moment, instead of a regular kind of expansion, it went whoosh, and then went back to its normal expansion. That whoosh thing we call inflation, okay? And that kind of inflation, if it happens in a multidimensional universe, it could happen over and over and over. So we could be, what we see right now is an inflationary space-time within a larger, more than four-dimensional universe. Or we could be this membrane bridging four-dimensional space-time in, again, something that's larger than what we would consider our universe. So Yeah, I'm sorry that I wish I could explain it a little bit more graphically or more visually, but just imagine a flag, two flags fluttering in the breeze, and every once in a while one of them touches, a spot touches here or here, and we might be that touch point.
Great answer. And you know, speaking of jingles, one of our listeners brought up a jingle. Jetsons, meet the Jetsons. They're
You
not,
mean the
wait,
Flintstones?
yeah,
Meet George
they're not.
Jetson.
They're your
Da, da,
modern
da, da,
Stone
da.
Age family. Think I'm getting things mixed up here.
From
Yep.
the town of Bedrock, they're a place in none of history, right?
Yep.
Yeah, you got your
Kind of like
tunes mixed
mass
up.
hypnosis there with the mixing of the jingles. But one of our listeners want to know, when are we going to get Warp Drive Jetson style? Or maybe he meant Star Trek style.
Yeah. The Jetsons had flying cars. I don't know if they ever went far away. They had extragalactic visitors. Of course, so did Fred Flintstone, right? The great kazoo, was that his name? That showed up
Yep.
and visited Fred. But Warp Drive, as far as Star Trek goes, seems highly unlikely. I don't know when we're going to get that. There is a Mexican physicist, his name is Miguel Alcubierre, who about a few decades ago anyway, I don't remember the exact date, but a few decades ago, came up with a mathematical structure to explain warp drive. What he basically hypothesized was, well, we've been talking about this four-dimensional space-time in which we exist, right? Now imagine if you could somehow create a pocket of space-time within the larger space-time. Remember I was saying that individual objects cannot move through space faster than the speed of light? What he said mathematically was that, well, a pocket of space-time can move faster than the speed of light in the larger space-time. So all you have to do is to surround whatever spaceship you want to fly in this sort of bubble, and thus you create this miniature space-time bubble that you can allow to fly through the universe at faster than the speed of light. So mathematically, that's a structure where you could actually create that. The only question is, can you actually engineer a thing that allows you to surround a spaceship with a bubble like that? Right? In Star Trek, they use this fictional thing called dilithium, and they create a bubble around them using warp nacelles and things like that, which is kind of cool. But I don't know when we're going to get that. It'd be nice to get it in the year 2063. That's when we're supposed to get it, right? I'm not spoiling Star Trek First Contact for anybody, am I?
Smitty does a good Scotty, don't you, Smitty?
Yeah, he did. Beam me up, Scotty. I mean, not Scotty. Scotty's the one beaming him up. Listen, I've got a question. Do you think time travel will ever be possible?
The question is whether time travel backwards will ever be possible. We're all traveling through time right now. We're traveling forward, right? Yeah, time is an unusual dimension. When Einstein was working out the general theory of relativity in the 19-teens, he had to recognize, and this is part of the reason it took him so long to work out the math, he recognized that whereas we can go forwards and backwards in length, width, or height, we cannot go backwards in time. We can only go forward. There was a paper published, I think a year or two ago, that gave a mathematical framework for the possibility of traveling backwards in time. But the problem is that our history, the way that time works, we are dependent on causality. The fact that we go forward only in time allows us to mark things like ages, birthdays, any kind of milestone, any kind of changes, whether on a subatomic or on a grandiose level, that's all dependent on causality. So if we move backwards, this mathematical paper that was published, I think somewhere in Australia, showed that even if you go backwards for a period of time, eventually your time always goes back to the causal thing that you were going to want to have been from in the first place. In other words, you travel backwards in time, you come back, and things basically won't have changed from when you left. Even though you might want to go back and change something cool, You can't do it. We don't know if that particular paper is correct from the physical perspective or, from the cosmological perspective. But it would be really interesting, wouldn't it, to be able to travel back in time. But it doesn't
Yeah,
sound like we can change the
definitely.
past, even if we could.
Very good. Yeah, I'm a historian, so I've always wondered that.
Wouldn't it be fun just to go back and just see stuff? I think
Yes, it
that
would.
would be
When
super
where
cool.
would you go back to? Where would your period in time? What would you travel back to
Oh,
see?
wow. Geez, there's so many different points in time that I would be very interested in. I think one of the places I would love to go is the Tang Dynasty, which ran from AD 618 to 907. That was a period of time when some of the best poetry in the world was written, some of the most amazing cultural phenomena. Most of the things that we associate with sort of classical Chinese culture and history originated roughly during the Tang Dynasty, what we would
Right.
consider the Middle Ages in Europe, right? And there was a flourishing civilization with all kinds of super stuff. I would love to just be a fly on the wall or spider under the table or whatever, and just see all that stuff happening, looking at the great poets and the great artists of that time, watching them do stuff. That would be super cool.
That would be neat. It would be. Where would you two like to go?
Mm,
CJ?
to bed. To bed every night. Just more sleep is all I need at this point.
It's
You
funny.
can go
My
back
I don't
kid,
need to go back
winter.
none of my three children slept through the night until they were 3 years old or older.
Oh,
So
don't tell me.
I understand
There's
your
hope,
situation, but
CJ.
you know what? But that's why I'm an astronomer. See, so guess who amongst me and my wife was the one who got up with the kids every night for 3 years plus per child. But I didn't mind it. It was part of my job description.
You just went out and studied the stars, huh? When you
That's right.
not a bad
Applause
idea.
deserved. So
I've got new motivation to go look out at the universe at 2:30 in the morning.
So to answer Smitty's question, I need to go forward. Wait, do I go forward to get a sports almanac or do I go back to get a sports almanac? I can't remember, but I need a sports almanac, and then I'll go back before the sporting events with my sports almanac. That's where I want to go.
But he just said you can't change history.
Wait a minute.
You can't change it.
I can't see
Then
myself
I would
fading
go.
away on my photograph.
I would get the sports almanac, go backwards, make a lot of money, invest in Apple, and then come back. So that'd be a win-win situation.
Got to get
Right.
back in time.
No, that would be nice.
We do not
I
own
would
the rights
actually
to
Right,
that
do you have
song.
any more
go
listener
to
questions we want to throw in there before we move on to hot takes, Tim?
We did have a couple more listener questions real quick before we get to hot takes, or if we're going to do any of the wheel of questions. Listener Jason Stifler wants to know, and I think this is a great question, Dr. Lou, if most galaxies have a black hole and the black holes are gobbling the galaxies and the time and the expansion of the universe, and they're all attracted to each other, when do we stop expanding and go back to the singularity?
It's a wonderful question. Turns out, as based on our observations of the universe right now, we're never coming back together. For some reason, space itself, as it expands, it gains speed in its expansion. If it did not, if like for every cubic inch of space, there were not just a tiny, tiny bit of extra expansion energy built into it, then eventually, yes, all of the matter in the universe, not just the black holes, but all the stars, all the dark matter, which is way more massive put together than the stars, right, would eventually draw us down together. It would slow down our expansion. And if it were enough, it would reverse the expansion and we would fall into something called the Big Crunch. As late as 20-ish years ago, that was a very real possibility. Our observations just weren't solid enough to know how much expansion power space had. But since about 1997, first with the Hubble Space Telescope observations of nearby galaxies, then followed by measurements of the cosmic microwave background and its geometry, and then followed by cosmological distances measured by exploding stars called Type 1a supernovae. All of that got put together, and we now are quite certain that space itself has so much power in its expansion that it's driving all the galaxies so far apart it will overwhelm gravity. And within a few billion years, right, estimates range from 1 to 1,000 billion years from now, all of those objects will be driven so far apart that there will no longer be any hope of pulling them back together again. This drive is often called dark energy, and it is 3 times more powerful than the gravity of even dark matter. So that's what's really driving the motion of the universe today.
That's amazing. Wow, I just can't even fathom that. I think we maybe have time for one more listener question, if that's okay. Listener Willie Mounts wants to know, apparently some UNC graduate students, by the way, shout out Chapel Hill, home base for CJ and myself. Some UNC graduate students recently discovered a trove of black holes. What are your thoughts on that? And does it change any of the ideas in the cosmos explained?
Where are these black holes that these UNC wonderful people discovered?
We don't know.
A trove of
Willie,
them?
find out for us and come on back. Send us the info, Willie, and we'll circle back to that question.
Yeah, I don't know.
Well, let me say that. Yeah, well, let me say it first of all. Hooray for UNC Chapel Hill's astronomy. I know some really, really good astronomers there, and some of them, the more senior members. Isn't there a Dean Smith Chair of Astronomy, or Dean Smith Professor at UNC Chapel Hill, named after the famous coach? I believe he endowed.
If not,
a
there
chair.
should be.
Yeah. Anyway, the person who held that chair for many years, I don't know if he's still holding that chair, was an astronomer named Jim Rose, who was a terrific guy. I hope Jim Rose was not the person who taught you astronomy that made you sad, CJ. I'm sorry if that was the case.
I did not go to UNC for undergrad. So.
She should have had the Michael Jordan Chair of Astronomy.
maybe. But what happened was that Jim Rose was doing some research, which I was very inspired by back when I was a graduate student, as I sort of continued the work that he was doing, talking about what happens when the black holes in the galaxies wind up congealing because galaxies themselves are colliding. When the galaxies collide, they wind up streaming huge amounts of matter into the central black holes of these galaxies. And thus you can create this thing called a quasar, which is very, very powerful. A quasar can emit more light in 1 second than our sun could in 1,000,000 years. This is really, really powerful stuff. But eventually that information subsides, and you wind up with a black hole just sitting there in the middle of a galaxy. There's no reason why there can't be many such galaxies with many such black holes just slowly moving toward one another, eventually coming together. It would not affect the way that our universe's history is going to work. Unfortunately, black holes simply don't have enough matter to affect the entire universe at any given time. They are powerful enough to affect entire galaxies. For example, the Milky Way galaxy in which we live is profoundly impacted by its supermassive black hole. But that dark energy expansion that's driven by this unexplained extra energy in space, that will barely feel even 1,000 black holes in a single spot.
So I have to say, this is actually headline 15 hours ago. UNC Chapel Hill astronomers find hidden trove of massive black holes. Sheila Knappen and Magda Palomera have found a previously overlooked treasure trove of massive black holes in dwarf galaxies. 15 hours ago. Breaking news.
Good for them. Good for Sheila. Um, the I think probably based on that headline, if we're talking about is black holes in dwarf galaxies are the issue here.
Yes.
You see, our Milky Way galaxy is not a dwarf galaxy. It's often referred to as what's called an L-star galaxy, which means it is very large. It's amongst the top 5% of galaxies in terms of the number of stars that it has. So it's actually quite large. And it's that kind of large galaxy that allows us to exist where we are, because it provides the stable gravitational environment from which our sun can form, a solar system can form, and you're not going to, say, get it torn apart by wildly moving stars back and forth. But dwarf galaxies, things that are, say, 1,000th the mass of the Milky Way, that's a different story. With that small amount of matter, we don't know if there are a lot of black holes in them. A few years ago, a scientist named Vivian Baldassare, she was one of the first pioneers to confirm the existence of these sort of intermediate mass black holes in dwarf galaxies. And since then, many, many other people have been studying and creating. For example, Mallory Molina, who recently tried to use what are called coronal lines to find these black holes in dwarf galaxies. And I guess now Sheila and her colleagues have done the same thing, finding even more galaxies. It's pretty amazing.
You are incredibly knowledgeable about so much. I can't believe how much you can just answer.
Well, I just love this stuff. I feel very fortunate knowing about the universe, and the whole point of being an astronomer and being a scientist is being able to share that love of the universe with everybody. No matter how much or how little we know, even a little bit is significant. It matters. We are, as I said before, as amazing and as ordinary as any star in the sky, any galaxy in the universe. And if we feel that and we share that with folks, I think it's a lot of fun. It's a great way to make a living. I feel very lucky.
Well, we are certainly lucky to have you on the show. And I think we should dive into some hot takes. What do you guys think?
Yep, let's do this. So, Dr. Lou, we'll just finish the show off tonight with some hot takes. I don't know if you've ever done hot takes before. Have you ever done hot takes? So
I have not.
Just hot button topics, some relevant especially to our show, some relevant especially to astrophysics, and we'll just pick a few out here. And it's
Okay.
your quick, super hot take on the hot button topics. Let's start
Okay.
with this. Are you familiar with Elon Musk's car in space?
I'm afraid so, yes.
What's going to happen to it?
Probably nothing for a really long time, and then it will have a spectacular crash.
Into the sun? Is that where it's headed?
Possibly.
Good answer. And I didn't know much about the Elon Musk car until CJ brought it up.
I'm so thankful
me.
for you for asking that question. I was dying to know.
CJ really want to know. I think it's going to go in the sun, and or it could get destroyed by something else. Who knows?
Mm-hmm.
Did we land on the moon?
Yes.
Good answer. What do you think about the future of space travel?
I think it's bright. I think it will be eventually, maybe 100 years from now, as common for human beings to be in space as it is currently now for us to be in the air on airplanes.
That's incredible.
Let's hope so.
Yeah.
Dr. Lou, are we alone in the universe?
No, we're not. The chances of extraterrestrial life existing are very, very high. However, the chances of them having come down to Earth, crash landing in Roswell, New Mexico, hiding amongst the populace, and then interbreeding with the locals, thus creating teenagers with supernatural powers who then have angst and issues when they grow up, the chances of that are essentially zero.
But it would be cool.
Yes, it would. Yes, it would.
I would
would
like
be
to have
cool.
a couple of those teenagers in my class. That'd be nice.
What is something that is still unexplained about the universe that you would like to see explained in your lifetime?
I would like to know what dark matter is made of, and I would like to know why dark energy exists. Dark energy and dark matter together comprise 95% of the contents of the universe. We don't know anything. I like to say that for everything that we've ever learned about anything we know about, there are at least 19 more things that we don't know about that we've never even thought about before because of dark matter and dark energy. So we have a lot to learn.
Well, speaking of dark matter, one thing I find confusing, and maybe you can clear this up, have we officially confirmed the existence of the Higgs boson, aka the God particle?
Yes, we have confirmed its existence. And the reason it's called the God particle is not because it's divine or it's anything more special than, say, other bosons, but because somebody long ago wanted to find it and couldn't find it and swore at it and basically said, oh, this is a God particle.
Where's my
And so a person wrote a book about it and wanted to call the book. They wanted to call the book the God particle. And the publisher said, I'm sorry, we can't use that word in the front of a book. So they just removed the part and just called it the God particle. And that's why it has been called the God particle ever since.
I do not think people understand that at all. I'll be honest.
No, that's awesome.
That's great. I think people think that, okay, if we prove the Higgs boson is real, we've proved God is real.
Right. No, it's a totally human story about this. It's about public relations, communications that a publisher did. Very clever, I should add. But no, as cool as the Higgs boson is, and it's really cool, right? With the Higgs boson, that's what causes us to move more slowly through the universe because we have mass, right? It imparts that drag against motion that we call mass, which is super, super cool. It is just one particle doing its thing. Photons are just as cool. They bring light to our eyes, right? They bring sunlight from the sun. Electrons are just as cool. Without them, we wouldn't be talking today. Our entire civilization is powered on the motion of electrons or the lack thereof.
Oh, yeah.
Right. And so, the Higgs boson is cool, but I wouldn't consider it any more divine than many of these other cool particles that we encounter all the time.
That's great. What's your hot take on Albert Einstein?
Smart guy, a human. We should celebrate him for the cool things that he did, and remember that everybody makes mistakes and everybody tries their best in life.
Would he be pleased at what we know about spooky action at a distance now?
Yes, he would, because he was a firm believer that mathematics could solve things. And the fact that we now know that spooky action at a distance can work in things like quantum entanglement, and that's actually confirmed through scientific experimentation, would make him very happy.
Maybe he would call it something else now.
Yes, that's what he would call it. He'd call it like awesome action at a distance or something.
That's great. It's officially renamed today. Hot take. Dr. Lou, what's your hot take on Stephen Hawking?
Stephen Hawking, what an amazing life to be able to continue to live with ALS all this time and still be able to contribute to the world with a wonderful mind, even though a body is gone. It just proves that there's so much dimension to humanity beyond just flesh and blood and beyond just simple thought.
Would we have astrophysics today as we know it without Sir Isaac Newton?
Yes, although maybe not as fast, because Isaac Newton was great. But just like Newton, just like Einstein, just like so many other scientists, there were other scientists working and thinking about these same sorts of things. The true breakthrough that they made was inevitable based on the number of people working on these projects, but it was just a matter of when. So we may be decades, even a century behind on our science today were it not for Isaac Newton or for Albert Einstein or some of these great scientific thinkers. But we'd still get there eventually.
Right. What's your favorite sci-fi movie?
Star Wars.
Had to be right.
The one
Go
true
watch it.
Star Wars. The only
too
Star
far.
Wars.
This is
Star
the-
Wars
Get-
is Star Wars is Star Wars. Yeah, you can add the words A New Hope
Dr.
after it. I
Lou,
don't mind.
Don't add
you
those.
might have just convinced me to go watch my very first Star Wars movie. Never seen a
Yay!
single one.
This is the way, CJ. This is the way.
What you do is you watch Star Wars A New Hope by itself, the original version from 1977. Don't think of it as some sort of massive arc or anything, but just think of it as its own little fairy tale about somebody doing something really cosmic in a really wild place in a battle of good versus evil. And that's the joy of that movie from that period of time.
That describes what I do at high school every day. Good versus evil. Good versus evil.
And I salute you for that, sir. You
Thank
know,
you.
I talk about the universe and I think deeply, at the university level or beyond, the national observatories using space telescopes, whatever. But you are in the trenches every day. You are making a difference in our society that I cannot. And for that, I salute you and thank you.
It's like
you
those
are,
old,
you
it's
really
like those old Bud Light commercials. Here's to you, Mr. High School History Teacher. Here's to
But
you.
Bud Light is not my beer of choice. I'm sorry.
What's your beer of choice? Hot take.
I have many, but it's definitely not Bud Light.
Craft beer,
If I want,
craft beer,
if
or
I want-
big box beer?
craft. I
There we-
definitely prefer, because any given time I'd like a specific kind of taste to my beer. I'm not drinking beer because it's beer, but I'm drinking it because I'd like to pair it with something or have a flavor or something or have an attitude of something. And so it can be a large brewery or a small one, just as long as it has that, special identity at that given moment.
I
I
like
will
that.
enjoy it.
I need to pair my beer with a particular attitude. I'm going to start doing that.
That's
I've only got two more hot takes for you, Dr. Lou.
Sure.
Bigfoot. Is he out there?
Bigfoot is probably out there, but not in the way that we expect it as portrayed by popular media. In other words, unknown creatures surely exist out in the wild. But are they big and hairy and kind of peek out between the woods and then escape before someone can actually, ask it questions? That is very unlikely. But I wouldn't be at all surprised if we found some really cool macrofauna somewhere in the world that has not yet been discovered at some point in our lives.
Yes. Great point. And finally, Dr. Lou, this last hot take is our most popular topic and also, ironically, the most closely associated with astrophysics. Congress recently had a hearing with Pentagon officials on this topic, UFOs. What's your hot take on
Yes.
UFOs?
Many things are unidentified and they fly, right? I probably have in my lifetime, maybe even yesterday, standing outside admiring the beautiful weather, and then something flew by. What is that? I don't know. It's unidentified. We may never know what that was. Maybe someone took a picture of it. What was it? I don't know. I can't identify it. I do not know. I can maybe ask a bird person, but the bird person's like, I don't know. It's too blurry. The chances that something unidentified that is flying past is observed is very high. And if we can't explain it through any other ordinary means, it doesn't mean it's weird. It just means it's unidentified. And it's worth exploring because it's kind of fun. And it's fun to our imaginations to imagine what it could be. But in the end, I'm not going to lose any sleep over it. We've all seen unidentified flying objects, and it hasn't really changed anything. That's my take. I guess, is that a hot enough take? Or is that too cold?
I think it's a good hot
Right.
take. Someone
That was pretty good.
Yeah, someone you probably have never heard of named Dr. Neil deGrasse Tyson said, "You know what? If you want to show me aliens are real, it's simple. Just drag one out to the town square, have everybody pull up, have a look at him. I'll give it to you. He's real."
Yeah, I don't want to drag anybody into the middle of the town square. I would invite this extraterrestrial and say, "Hey, would you like to meet some of my friends? You want to hang out and take it easy? You know, maybe offer you a beer. I mean, could be Bud Light or craft beer, whatever you prefer. And let's chat." That's what I would like to do.
Share it with an attitude.
Why drag anybody?
Oh,
That would definitely
I do
unite
want
us
to
all. One beer to unite us all.
Since I went to get all these questions, I want to ask one that I did pull, and it was we were going to do Wheel of Questions, and one of the questions was, when you were in high school, what's something in your locker that other people would find strange? I thought that was a cool question.
Maybe an old comic book. When I was young, my brother, who's a couple of years younger than me, for Christmas, gave me a comic book because he knew I liked comics, but we couldn't afford buying comics really. I didn't collect them until I was in high school and actually had a job delivering newspapers. But when we were younger, he bought a comic book for 35 cents, which I deeply appreciated. And it was Avengers 179, featuring a forgettable villain called Bloodhawk or something like that. I think the Bloodhawk, who turned out to be a misunderstood mutant creature. But the actual villain was some other dude. It was terrible. This comic book featured Black Panther in it also, before he became famous, and all these other wonderful people. Yeah. Vision, Scarlet Witch, etc., etc. And so I probably had that Avengers 179 in my high school locker the whole time I was in high school. It just sort of sat there. And I think I still have it somewhere, but now I've put it in a plastic bag and have a cardboard backing on it or something like that. It has no value of any kind. No one will buy it from me, but I still remember that as an act of generosity from my little brother.
Yeah. It's a sentimental value. Sometimes that's worth more than monetary.
And spoiler alert, I'm pretty sure that is the synopsis for Black Panther 2.
You heard it here on All Things Unexplained.
Well, Dr. Lou, if we can have just 5 more minutes of your time. We did force Smitty to put all of these questions together. We sent 18 text messages, Smitty. Do you have the questions? So these are just fun, not related to astrophysics whatsoever, but similar to what he just asked. We've got a few more for you.
Sure.
If you could sing a duet with anyone, who would it be? I'm assuming you're going to say me, but go ahead.
Well, you would be high on the list for sure.
Thank you.
But I would say the person right now I would love to sing a duet with right now is Ariana Grande.
She can sing.
It seems kind of more. She is pretty amazing. Did you see her Saturday Night Live, where she played the intern at some satellite radio corporation, and the satellite radio feed was down, and they had to create a live feed instantaneously, and the intern was Ariana Grande, and she basically played or sang snippets of every single well-known pop singer just immediately off top, and she sounded exactly like them. Tremendous talent.
Wow.
Tremendous talent.
I've saw her do that on
Jimmy Fallon.
I saw her do that on the Tonight Show. She plays what was that? The TikTok challenge with Jimmy Fallon.
Right. I heard about that. I never saw it. Maybe I should go find it.
Here's a good one. When you were a kid, did you have any posters on your wall? If so, what?
I did, actually. The poster I remember on my wall was a bubbling brook with some trees and some road. It was very, very generic. It didn't have any like celebrity on it, except it had a quote. And I hope I get the quote right. In matters of principle, stand like a rock. In matters of taste, swim with the current. Attributed to Thomas Jefferson.
Oh, very cool.
It's
I know,
beautiful.
pretty geeky
Very
poster.
cool.
Right? I mean,
I was
I should have had like
expecting
Mark
Van
Hamill
Halen.
and Harrison Ford or something like that.
I only had Jonathan
I
Taylor
had a
Thomas
big
on my
Michael
wall,
Jordan
so.
poster. I had Jordan slamming from like the free throw line.
Nice.
And I didn't even like basketball. But if you could have anything named after you, what would you want it to be? If you could have anything named after you, what would you want it to be?
A college or a scholarship fund where students who loved the science, regardless of how they did on their SAT scores or whatever, could go and get a college education in the field of their choice for free just because they love to learn.
Very cool. That's tremendous. That's a great thing.
Not ambitious or anything like that, but, but that's what I'd like to have happen. I think we all should have that opportunity. I wish we all.
I agree. That's a great answer. We sure
All right,
haven't
Smitty,
enjoyed
hit us with
being
one more. Let's get one more of those
One more.
questions, and then we'll
Okay.
wrap it up.
Would you rather put ketchup or ranch dressing on everything you eat? This is a real intellectual question. Would you rather put
An excellent
ketchup
question to end on.
or
I am more of a sweet tooth person than a savory person. So for me, the answer would be ketchup.
There you
The
go.
exception, I put ranch dressing on chicken fingers because for some reason, ketchup on chicken fingers makes them taste like French fries. And I would rather have the ranch.
My son
There you have it,
eats
folks.
probably about a gallon of ketchup a month. I mean, literally a gallon. Maybe more. So.
Wonderful. Well, you tuned in to get astrophysics, and we talked about ketchup and ranch dressing at the end, but that's exactly how these things should go, in my opinion. So.
You got to bring up the most important things in life. What's more important than ketchup and ranch dressing?
And remember, ketchup and ranch dressing are part of the universe, right?
That's exactly
It's
right.
all part of
Mixed
the universe.
together are delicious.
It's all
how
stardust.
That's right.
That's right.
That's what it is.
But before we head out, Dr. Liu, tell our listeners where they can find you.
Thank you. I tweet at Chuck Liu, CHUCKLIU. And if you search for the Liuniverse podcast, it's on various places. And I believe, yes, if you even type in Charles Liu, The Cosmos Explained, it'll point you to various places online where I exist. And you can get some information about the universe and have some fun with it too.
Yes, lots of fun. The Instagram account is very fun. So everybody go and follow Dr. Liu on his Instagram account.
You have been
It's
a
very
tremendous
entertaining.
gift. Tremendous
Oh,
gift.
you have been tremendous hosts. Thank you so much for having me and for asking fun questions. I mean, we're just having a good time here, and that's a great thing to do. I'm a big fan. Thank you so much.
We need to have a comic book edition. That would be awesome. That would be awesome.
I'll go watch
And
the
if
first Star Wars
you-
movie before we do that.
Oh yeah, go see a Star Wars movie, and then let's do a comic book thing. We can do a Star Wars thing. We'll do a Star Trek thing. We'll do anything. I don't care. Pick something.
I'm more.
We did have a
I'm more
special
of a Star
episode
Wars.
where we went on the search for Smitty. So
Search for Smitty. Well, you can usually
That would be
find me
Star
sitting in
Trek
this
3,
recliner.
Smitty Trek 3.
Smitty in the Smitty. That's usually where I'm at in the recliner after work. So, but
we
sure
did find
appreciate
him.
it. You want,
Is it time
you
for
want me to
Larry to
take us
take us
out?
out? I think I got Larry for us. Dr.
I
Lou,
want
thank
to-
you so much.
hang on a second.
Thank
I want to wish my wife her birthday's tomorrow, so she's gonna be a certain age, I'm not going to reveal it. But happy birthday, Marty.
Happy birthday, Marty.
Happy birthday.
Happy birthday.
And
Are we out?
we're not out, but you can keep talking
All things
over the exit video.
unexplained.
It's fine.
All right.
I got to.
All things unexplained.
What's your hot take on Travis Taylor?
I've got an exclusive for you guys if you want it about the
Yes,
Alaska.
we do.
Okay.
Dr. Taylor was revealed to be the chief scientist of the UAP task force with the Pentagon.
So some of that, I think, sir, we'll save for closed session.